So projectile, so travel path of a projectile. If you throw a particle with some angle to the ground with some velocity, then the path will follow this. The particle will follow this path. This path. Then it will come to the ground. Now something to notice. So this is my ground. If you throw a particle this way, it will go this way and come back to the ground. Now this path we call horizontal range, or simply called range. Horizontal range. Something to think about, that there is g. G is always downward. G is always downward. There is no acceleration in horizontal direction. So do not forget these two items. G is gravitational acceleration or gravitational constant. It always acts downward. No exception. There is no horizontal acceleration in projectile. Now question is why? When you throw a particle is done, you are not applying any more force. So you are just throwing from at the beginning and that is done. You are not applying any more force. If we apply any more force, yes, then there will be acceleration, but that is not common. Then it will not be a projectile. It will be a motion in a inclined plane. That is defined story. So in projectile there is no horizontal acceleration. So at least do not forget this. Now if I write the equation b equals uh, at plus b naught. Actually in our equation I write b naught earlier, I forgot. So initial acceleration, which is initial velocity, oh right here, initial velocity with some angle say theta. Now if it is x directions, then bx and b naught x. If I consider everything in x direction, you can see ax, everything in x direction. So here x direction, then Vx, Axt, and B naught x. Now, as I told you, there is no Ax. Ax is 0. That means this portion is 0. Okay, let me take a new color. So that means this portion will, what happened? Oh, it is gone. So I need to write it down again. I know how it is. Okay, write it down. Oh no, it is here. Okay, so x direction, as Ax is 0, this portion will be 0. Then what is that? V at any point equals whatever the initial velocity, that is the velocity. Now what does it mean? It means in my entire path, my x component of the velocity, in the entire path, my x component of the velocity is v naught x, which is v naught cosine theta. Yeah, my this v become bigger, but entire path, but a horizontal component of the velocity is constant, that is v naught cosine theta. What about v naught y? Now the story is about v naught, sorry, vy equals v naught y minus z t. You can see z is plus minus. Why plus minus? When we'll go up, my z is downward, z is downward, z is downward, yes, z always downward. So my vertical velocity at the beginning very high, then decreases, then decreases, then decreases, 0 here, then increases this way, increases this way, increases this way, increases this way. So Vy, what will happen? It will start decreasing and become Vy 0 here. At the highest point, Vy is 0, but Vx is there. Do not forget the Vx. Vx is there. Vx does not change, but Vy becomes 0. When it comes down, Vy keep on increasing and Vx remains the constant. Okay, so we learned another theory that By decreases with elevation, and when it come down, it increases. Whatever the time required here and here equal. So total time of flight or travel time is double up, upward or downward. What else? Yes, these are the theory. I think if you understand this part, this portion, you are good in the projectile. But I do not think anything difficult or vague here. Now something else to derive some equation. Yes, in your handout, I also derived some equation based on this. Now our concept is this. There is no more new concept. Now what is the equation valid? Whatever equation we learned in the previous classes, same equation is valid. This, that is b equals b naught plus gt. Now I am not writing the sign. Sign may always uh, change. So a is equals b naught t plus half gt square, and it is valid in x direction and y direction both. So this equation will be valid in x direction, y direction both. I am not writing both side. These three equations valid in projectile in x direction, in y direction. Okay, now I will go through the handout. In handout, I derive. Oh, before handout, so I listed all the equation. Whatever I told, I just listed here. Now, next question: what is the time to peak? Time to reach the peak. That means the t. Yes, we can derive it. How can we derive it? If we use the equation, that means if we use this equation, let me take a new color. If we use this equation just in the half of this, then we will find time to peak. How do we know? By is 0. So By equals By naught minus Gt. Why minus? I am assuming by V up, this velocity is positive, vertically upward positive. So this will be 0. V naught, Vy naught will be V naught sine theta. Z is known, T is this. Then if I simplify, T equals V naught sine theta by Z. So that is time to go to peak. The same time to come down. So that is time to peak. What is time to return? Same time, total time times 2. So you can see deriving equation is nothing about the same thing we learned, that it is actually this equation. But sometimes we derive to make it a handy equation that we can use it anytime. Let me see whether it is right or no. Sometimes I try to show over smartness. Oh, but no, it's right. Yes, as long as you follow the logic, you will get the answer. Okay, let me move it. Next is, what is the maximum height possible? Again, without seeing the solution, we can derive it. How? Uh, Green color. So again, height. So we will use this equation in this segment. Then we will get the maximum height. How? Okay, I'm taking a new slide. So when what is my equation? Equation is v naught square v naught y square minus twice g a's. Upward, I am assuming positive. Now we know at the highest point my v y is 0. What is this one? V naught sine theta square minus 2g a's. Then simply my a's is v naught square sine theta square by 2j. So you can see we can derive this equation. You can use these equations directly if you need, or you can use this equation to derive it. There's nothing rocket science, it's just common mathematics. Okay, now let me check whether I did the right derivation. Where's my cursor? I found it. Come here. I use the, oh, here they use in a different, oh, it looks my equation is not matching. It looks my equation is not matching. That means b square. No, no, I made a mistake here. You can see here v naught square sine theta square minus this. So there will be a square, square here. So in your handout, write it down. There is a square here. Yes. Or let me go back to check again. Yes. All over sine square. Yes. Even here I made a mistake. Let me check it. Right. Here there will be a square. V naught square sine theta square. Okay. So write it down. Done. Yes. So you can see here they used in a different ways to derive it. They used the other equation, and in that equation they inserted the value of t. That is okay. Yes. There are many ways to solve a problem. Third, what is the maximum range? Oh, maximum range means the horizontal distance. How can we derive it? Many ways. Not many, several ways. So what is this? That is the question. Or maybe we can write x. Whatever you write, what is this value? Now, two many ways you can do it. Obviously, one equation may be like, um, we know that this way there is no acceleration. Acceleration is 0. So this way my distance travel is Vx naught times t. Now this t means entire time. What is Vx naught? Vx naught is V theta cosine theta, which is Vx. What is my t? If you can remember, we found our t. I forgot t. Most probably to, yes, we derived a equation for t. If we insert the value of that t, you can find it. So I will take the help from my handout. I did not memorize it. Yes, even you do not need to memorize anything, just the concept. As long as you know the concept, yes, same thing. Whatever I was doing, they did the same thing. So x naught is vt. Why this equation? Because there is no acceleration. I inserted the value of vx and then value of t. T is this. After solving, we can find it. Now we can use this equation or we cannot. I'm just showing you how. Then trajectory equation. What is this? It is the entire path equation for the entire path. How to find it? Whatever our general equation, in that equation, if we insert the value of t, then you will get y in terms of x. Now they found this equation. After finding, they found that tan theta is constant, because whatever we thrown the angle, tan theta will be constant. This portion will be also constant. It will not change. So we can use this equation. We can write this equation as y equals ax. Then this portion is say b px square. So that y equals ax plus bx square here. And this equation is the general equation for a parabola. So this is why if we throw a particle vertically upward with some angle, then the travel path will be a parabola by theory, and it is true. Our vertical curve is also parabola. That is why it is important. Now some rule to remember. I already told this rule again to refresh your mind. Vertical component of the velocity decreases with height. We saw this. Reaches 0 at the peak and increases downward when it returns. Now why it decreases first? Because gravity pulls it down. Why increases when it comes down? Because gravity helps the particle. Rule number 2, gravitational acceleration always act downward and is considered constant at a plane. is constantly at a place, no, but it is not always same. Why not always same? Some, if I draw our earth, uh, maybe not exactly this, our earth is like this. So here my distance is very high. So when the gravity will pull me, they will, here g will be less because distance is high. At this point my distance is less, say r prime. Here my distance is less, so g will increase here. That is why the value of g changes. Now if we are located in the middle versus we located here, it will change. Z always not constant, but at a plane, say in America, say in see America where inside this world, I do not know, maybe we are here. In this small segment, it will not change. If we go on top of the mountain, yes, it will decrease because mountain means says something like this. We are here. It will decrease a little bit, but we do not uh, keep that in consideration. We always use Z is 9.8 on or 32.2, whatever the unit you can write. Okay, so I'll go here. No horizontal acceleration, as I told you. Why? No change in velocity in the horizontal direction because no horizontal acceleration. At any point of the travel path, velocity has two components. Yes, any point, two components, except at the peak. At the peak, there is vertical component, and that is 0. The distance travel is the algebraic sum. Algebraic sum means like we will consider the sign going up 10 feet, going down minus 10 feet. Algebraic sum is 0. That means in the entire path, if the question asks what is the vertical, what is the y of a projectile, answer is 0 because going ups and coming down, vertical distance is uh, vertical displacement is 0. Come, okay, something else also. While while analyzing, the motion can be treated as two independent one-dimensional motion. That means we can consider a motion in x direction, a motion in y direction individually, separately. Yes, you saw it when I derived the equation. I used only y. And when I derived the equation for range, I used only x. So you can do, or you can consider two motion separate, no problem. In fact, we do it every time. Okay, let us see some. What is our time? Oh, not 10 minutes left. Okay, so we will not see the solution. We will see the solve it this one. Now, one problem can be solved many different ways. No problem. Answer must be same. Question number this one, 2-22. A projectile with an initial velocity of 50 meters per second is launched at an angle of 45 degrees with the horizon. Calculate the horizontal distance traveled by the projectile. 50, 45, 50, 45. So this problem is telling a particle is thrown 50 meters per second at 45 degree angle. Oh, what is the question? I think it is the horizontal distance. Come. Yes, horizontal distance travel. Now, two ways. One is you can go back to your handout and find the equation and directly use this and done it. What is that? Horizontal distance is the maximum range. This equation. That means it will go up and come back. This distance will be how much? X will be b naught square sine 2 theta divided by z. Did I write correctly? Check one more time. Yes. Now, if you go back to equation, your book and just use the equation, then you do not need to actually understand anything. Whatever you will get, this portion is 1, sine 90 is 1, I can memorize, and then you will get an answer. Done. On the other hand, if you want to find it in different ways, you can do that. Now, what are the different ways? The same ways how we derive this equation. How we derive this equation, same way you can find it. But do you want to? Yes, if you want, no problem. I'm showing you how. So 50 meter per second, angle is 45 degree. So to go up and come here. How to find it? This way we know that it will be Vx naught times t. So B naught is B naught cosine 45. What is t? You can derive it again from the beginning, or you can just write the equation. Is it this equation? Yes, similar to the yes, it is this equation. If I can remember, I do not need to go back and say. So you can calculate this way, or you can start from the beginning. How to find t? Okay, here to here your time is t. I think in my handout I did that. I did not solve in a straight way. Let me see what I did in my handout. But I showed you different ways you can solve that problem. Okay, horizontal component of the velocity. See what I did in my handout? Very difficult way. First, I calculated the time to reach the peak, 3.5 seconds. Then time to come back, 7.2 seconds, double of this. Then, okay, and I wrote here. Alternatively, you can calculate the total travel time of flight as this directly. But I did not do it. Why? Just to show you that different ways we can do it. Then we came to the point x equals x naught b naught, sorry, b. This is the x component of velocity along horizontal direction times x naught is 0 because our reference point is 0. So we are coming to the point directly. Or alternatively, there's different ways also. Not only, I will say, you can simply use this equation. Alternatively, you can use the equation. No need to write the entire equation, write a short equation. Yes, so many different ways. Done. So hopefully you understood like how I solved this problem. Okay, so I will stop.